How does a diuretic lower blood pressure? When a person takes a diuretic, water loss via urination increases. As a result, blood volume decreases and blood pressure decreases as well.
The opposite happens with the parasympathetic stimulation. You may have experienced that your blood pressure goes down when you are in meditation or when you're sleeping or doing breathing exercises. So let's see how that happens. When the parasympathetic stimulation increases, it affects both the arterioles and the heart. So the parasympathetic stimulation increases. There's the arteriole, and here's the heart. It has a negative effect on both. On the arteriole, it causes vasoconstriction to go down, which means that majority of the blood vessels that are in the abdominal region dilate. So when vasoconstriction goes down, peripheral resistance goes down as well. When the overall peripheral resistance goes down, blood pressure goes down as well. Now for the heart. The parasympathetic stimulation lowers the heart rate. It does not have much effect on the contractility, but it does lower the heart rate. When the heart rate goes down, the cardiac output goes down as well. When the cardiac output decreases, blood volume decreases. When blood volume decreases, blood pressure decreases. So there we have it again. Peripheral resistance and blood volume influencing blood pressure.
Let's see how calcium channel blockers lower blood pressure. When a person takes calcium channel blockers, calcium permeability at the SA node decreases. As a result, calcium inflow decreases as well. So, the depolarizations are slowed down. So, slow depolarizations at the SA node, leading to fewer action potentials per minute, which means fewer heartbeats per minute. So the heart rate goes down. When the heart rate goes down, the cardiac output goes down. When cardiac output decreases, blood volume decreases. And when blood volume decreases, then blood pressure decreases as well. Let's see how a vasodilator lowers blood pressure. When a person takes a vasodilator, vasodilation increases. This results in peripheral resistance decreasing. When peripheral resistance decreases, blood pressure decreases as well. Angiotensin converting enzyme, also known as ACE, is produced by the lungs, and its job is to convert angiotensin 1 to angiotensin 2. Angiotensin 2 is a hormone that raises blood pressure. People with high blood pressure are sometimes prescribed ACE inhibitors. An ACE inhibitor does just that. It inhibits or blocks ACE from doing its job. So angiotensin 1 cannot be converted to angiotensin 2, and blood pressure stays low.